Hello, welcome back again. Now what I want to look at is the star delta or T-pi transformation theorem. Now the term star and delta refer to two types of network commonly employed in heavy current engineering. Now notice the term heavy current, okay? And this would involve quite possibly high voltage transmission systems. Now I don't really want to spend time reading this to you, of course you can read this for yourselves, okay? And as you can see that the information is quite readable. Now it can be seen that the T network is just a star network drawn upside down, and the pi network is a delta network. Okay. Now I need to make sure that you can understand and use the information, so look at other resources, see how other people have done their calculations, see what you can learn from that. Now here you have a star network, okay? Again, always draw out the diagrams, take down the information, make it your own. Once you've written something, the brain does not forget it. Use it. Okay? And here we have the delta network. Okay? Again, I'll turn back a bit so you can get everything in. Okay? Now, make sure you draw the information as given and extract the information as required. Okay. And here you have the T network, which represents the star system. Okay. Now look at the diagrams, look at the drawings, draw them out, take them down. Don't leave them and assume that you can do it from the screen. That will not work, okay? And here we have the delta network. The pi and the T networks has been modified to emulate the star and delta network as shown. Now make sure that your extraction of information is correct and don't leave out anything, otherwise it will not make sense. Okay. Now here I'm just looking at the delta to star. And here we're looking at the equations which makes up the impedances of the relevant circuits. Because while you're dealing with high voltage or of nature, you will come across impedances, and those impedances has to be taken into account. Okay, and what this formula does, equations I should say, is allow you to put them in a manner which allows you to arrive at a solution to resolve the impedances, whether they're in parallel or otherwise. Now there's quite a few equations, and I've actually put them down because they are relevant. They're used for different parts of the circuit. Okay. And you'll notice that there's some subtraction of equations and replacing of equations. I've tried to show that the best I can. Now, get familiar with transposition, okay? So you know how to transpose from one formula to another. Okay. And here will be a lot of equations that you need to know and be able to apply. Now, it is important that you do some additional research so as to enable a better understanding of the information provided. Now, that is important. Look and do a little bit of reading for yourselves. Okay. And here I'm now looking at star to delta. Okay. Just with terminals B and C short circuited. Okay. Bear that in mind. Look at the formulation used. Okay. Now here you have a diagram, draw it out, okay? And then we go on to a simplified version of the same diagram after we've calculated the impedances. And here again you have diagrams drawn, okay, and here we come to the simplified version overall, down to the final circuit, which gives us our solution. Now remember here, this is our final solution, okay, from all that work above. Okay, thank you for your time, okay, and I hope you find this information useful. Let me just flip back up a little bit to make sure that you can see this in completely. Okay. Okay. Thank you.